Alien comet scientists are racing to study before it's gone forever. Right now, something is moving through our solar system that doesn't belong here. It came from another star. It's been drifting through the cold void between galaxies for possibly 10 billion years. And in a few weeks, it will be gone forever, swinging past Jupiter and accelerating back into the darkness, never to return. Its name is 3I/Atlas, and scientists all over the world are racing against time to learn everything they can before it vanishes. July 1st, 2025. A telescope in the mountains of Chile picks up a faint speck of light moving across the sky. It's part of Atlas, a network designed to spot dangerous rocks heading toward Earth. That night, it found something far more extraordinary. Within hours, astronomers ran the numbers. And the numbers were wrong. Wrong for anything that belongs in our solar system. The object was moving at 137,000 miles per hour. Too fast to be held by the sun's gravity. Its path curved outward in both directions, arriving from deep space, swinging around the sun, and heading straight back out again. A one-way trip. This was not from here. Scientists confirmed it quickly. The Minor Planet Center gave it an official name, 3I/Atlas. The 3I means third interstellar object, only the third visitor from another star system ever detected in human history. The first was Oumuamua in 2017. The second was Borisov in 2019. Now this, already more active, more dramatic, and more scientifically rich than either one. So, what exactly is it? At its core, 3I/Atlas is a comet, a solid, icy body releasing gas and dust as sunlight heats it up. Hubble images revealed a teardrop-shaped halo of dust around the nucleus, with a long tail streaming behind it. Scientists estimate the solid core is somewhere between 0.5 kilometer and 5 kilometers across. That's a wide range. Pinning down the exact size has been one of the key challenges. But size isn't really the point. What matters is what it's made of. NASA threw everything at it. Hubble, James Webb, TESS, Swift, Parker's Solar Probe. Virtually every major space telescope was redirected to study 3I/Atlas during its passage. On the ground, observatories across the planet tracked it around the clock. Even spacecraft already heading somewhere else, including the Psyche mission, the Lucy probe, and the Europa Clipper, were used to gather observations from different angles. The Europa Clipper may have actually passed through the comet's ion tail, a stream of charged particles flowing off the nucleus. If so, its instruments could have collected physical material from another star system. Those results are still being analyzed. Here's where things get genuinely strange. When the James Webb Space Telescope analyzed the gases coming off 3I/Atlas, it found something immediately puzzling. In comets from our own solar system, water vapor dominates. Carbon dioxide is a minor ingredient. But in 3I/Atlas, the ratio was roughly 8 parts CO2 to 1 part water. Carbon dioxide, by a wide margin, was the main event. Why does that matter? Because CO2 ice only survives in extremely cold environments, far from any star. This comet almost certainly formed in the frozen outer region of a completely different solar system, under conditions quite unlike our own. There were other surprises too. Scientists found carbon-based molecules similar to those in our own outer solar system comets. They found silicate dust with unusual optical properties, grains smaller than a single micron, unlike anything seen in solar comets before. And one more puzzle that still hasn't been solved. When 3I/Atlas was still far from the sun, too far for water ice to normally evaporate, it was already releasing water vapor. Scientists are still working out why. The comet also rotated roughly every 16 hours, with jets of material erupting unevenly from its surface, like a pinwheel spinning off center. This kind of lopsided activity usually means an irregular nucleus with pockets of different ices just beneath the crust. Where did it come from? Astronomers traced its path backward through space, checking its trajectory against catalogs of nearby stars. No single star system matched perfectly. What they could determine, based on its speed and direction, 3I/Atlas most likely originated somewhere in the older, denser part of the Milky Way, a region with different chemistry and different history than our own neighborhood. Statistical models suggest it has been drifting freely through interstellar space for approximately 10 billion years. 10 billion years. The Sun is only 4.6 billion years old. Earth didn't exist yet when this comet left its home star. The dinosaurs were still hundreds of millions of years in the future. The continents hadn't formed. For all that time, 3I/Atlas traveled in absolute darkness at temperatures near absolute zero, steadily bombarded by cosmic radiation. Its outer layers are ancient and hardened, a crust built up over eons. But underneath, pristine ice, chemistry preserved from a star system that may no longer exist. 3I/Atlas is, in a very real sense, a time capsule, a message in a bottle from a world that died before our world was born. Of all the spacecraft that observed 3I/Atlas, one has the most dramatic story. ESA's JUICE mission, the Jupiter Icy Moons Explorer, happened to be passing through the inner solar system in November 2025 on its way to Jupiter. Scientists seized the opportunity and commanded it to point 5 separate instruments at the comet. There was just one problem. JUICE was so close to the Sun that it had to use its main antenna as a heat shield, which meant it couldn't transmit data back to Earth at full speed. Scientists had to wait until February 2026 for the full dataset to arrive. When it did, the images were remarkable. JUICE's camera had captured more than 120 frames of 3I/Atlas during a critical observing window. The key image, taken on November 6th, just 1 week after the comet's closest approach to the Sun, showed not just a tail and glowing halo, but jets, streams, and filaments radiating outward in multiple directions. Scientists across 5 different instruments are now combining all of that data. Their integration meeting is scheduled for late March 2026. The analysis is just beginning. Right now, in mid-March 2026, 3I/Atlas is approaching Jupiter. On March 16th, it will pass within about 53 million kilometers of the gas giant. That's close enough for Jupiter's enormous gravity to slightly bend the comet's exit path. But the more exciting possibility is what that gravitational tug might do to the comet itself. As the nucleus is squeezed and stretched by tidal forces, cracks could form, splitting open pockets of ice that have never been exposed to sunlight. That could trigger new outbursts of activity, briefly brightening the comet and releasing chemistry locked inside since the day it formed. NASA's Juno spacecraft, currently orbiting Jupiter, has a potential monitoring window between March 9th and 22nd. Even a low-resolution image from Juno would give us the first close-up look at an interstellar object from within the Jovian system. The science team is weighing whether it's feasible. Juno is aging and low on fuel, but the potential reward is extraordinary. After this encounter, 3I/Atlas will accelerate away from the Sun, growing dimmer month by month until it fades beyond the reach of even the most powerful telescopes. Then it will spend the next tens of billions of years in the dark between stars, carrying traces of our solar system outward, just as it carried another star's chemistry inward. So, what have we actually learned? And why does it matter? Compare the 3 interstellar visitors we've seen. Oumuamua was bizarre, elongated, tumbling, accelerating without any visible outgassing. Still unexplained. Borisov was familiar. Clearly a comet, with detectable water and carbon monoxide, strange only in that it came from somewhere else. 3I/Atlas falls somewhere in between. It behaves like a comet, but its chemistry is alien. And yet, the most profound takeaway is this: the chemistry works. 3I/Atlas contains the same building blocks we find in our own solar system's comets: carbon, oxygen, organic molecules. The physics and chemistry of comet formation appear to operate the same way across the galaxy, regardless of which star did the cooking. This suggests the raw ingredients for planets, and potentially for life, aren't unique to us. They seem to be distributed throughout the galaxy, following the same rules, producing similar results around star after star. Every star system might be sending comets like this one drifting across the galaxy for billions of years. Occasionally, one falls into another star's gravity. For a few months, 2 worlds briefly touch. That's what 3I/Atlas is. A handshake across the galaxy from a star that no longer exists, reaching across 10 billion years to say, we were here too. By the time you watch this, 3I/Atlas may already be beyond the reach of amateur telescopes. Scientists will keep analyzing the data for years. Papers will be published, Models will be refined, but the comet itself will be gone, accelerating back into the dark, back into the silence between stars. It came from another world. It spent 10 billion years in the void. It swung around our sun, gave us a glimpse of alien chemistry, and now it's leaving. We had one shot to study it, and humanity, with every telescope and spacecraft we could point at the sky, took that shot. That, to me, is what science is: an act of attention, a refusal to let the universe pass by without asking what it is. If that's the kind of question you like asking, subscribe. There are more mysteries out there than we have videos for, and we're just getting started.